In this video, we're going to look at when to add or multiply exponents. So in the first example, we have 2 to the power of 2, which is the same, if you remember, as 2 times 2, multiplied by 2 to the power of 3, which is the same as 2 times 2 times 2. So if you take a moment to figure this out, you'll see that 2 times 2 is 4, times 2 is 8, times 2 is 16, and then times 2 again is 32. So however you go about this, you might notice that this answer is 32. But this is I guess a harder way of doing this, because all you have to do is count how many 2's there are. 1, 2, 3, 4, 5. So this is actually 2 to the power of 5. So I guess my question is there a pattern that we notice? If you start with 2 to the power of 2 times 2 to the power of 3, and you get 2 to the power of 5, well, it seems to me at least that 2 plus 3 made 5. By that logic, if ever we tried a different one, let's say 3 to the power of 2 times 3 to the power of 7, well, what did we do last time? We just added the exponents. So we could just add these exponents. Now, it turns out this only works if we have the same base on both and it's being multiplied. So this would be 3 to the power of 2 plus 7, which is the same as 3 to the power of 9. That would be a situation where you would add exponents. But what about this one? This one's a bit different. So with these brackets, we have to consider the order of operations. So inside of the brackets, for example, 2 to the power of 2 is like 2 times 2. And the entire bracket is raised to the power of 3. How do we think of this? Well, we have to introduce something here called bedmass. I will be mentioning this more in the future, but bedmass stands for bracket, exponent, division, multiplication, addition, and subtraction. So anytime that we are dealing with algebra, or in this case, we're in a pre-algebra course, so we still have to familiarize ourselves with this order of operations. We have to figure out what are inside the brackets first. And then afterwards, we can apply the exponent. So what I mean by this is we would have to do 2 times 2 first. Figure out what that makes. So 2 times 2 is 4. And now this makes 4 to the power of 3. So 4 to the power of 3 is 4 times 4 times 4. And so 4 times 4 is 64. And then 64 times 4 is, well, I'll need a calculator to figure that one out, 256. So, okay, is there a better way to do this? Well, I'm going to think about this a slightly different way. So recall the question here was 2 to the power of 2 in brackets all to the power of 3. So I'm going to copy that again. 2 squared to the power of 3. And we said that 2 squared is just 2 times 2. all to the power of 3. Well, anything raised to the power of 3 means you multiply it by itself by itself. So even if it's a thing that's in brackets here, so even if it's the 2 times 2, all in brackets, that gets multiplied by itself a total of, well, twice, so that it appears 3 times, like this. And so how many 2's do we see here? Well, there's 1, 2, 3, 4, 5, 6. So this actually makes 2 to the power of 6, which if you were to try this in a calculator, you would get 256. I want to see if there's a pattern here. So we started with, what did we start with? We started with 2 squared to the power of 3, and our result was 2 to the power of 6. Now it turns out this worked because 2 squared to the power of 3 is actually a multiplication of the exponents. So anytime you see a bracket right here separating 2 exponents, it makes a multiplication of the exponents. So this is actually 2 to the power of 2 times 3, which is 2 to the power of 6. Here's another one. 4 to the power of 2 times 2 to the power of 3. So I oftentimes see this mistake being made. So warning, do not do this. Do not do this. So I've seen people take the 4 times the 2 and make 8, and then take the 2 and the 3, and recall the first rule is we tend to add the exponents when the base has been multiplied like this. So yes, people would wrongfully put 8 to the power of 6. So this is not correct. The actual correct way to do this is, and the reason it was not correct is because you have to have the same base for both of these that are multiplied together. If they're not the same base, we have to find some way to represent them as the same base, if that's possible. So 4 to the power of 2 times 2 to the power of 3. Well, 4 is just 2 squared. So if I replace the 4 with a 2 squared and I change nothing else, it looks like this. Recall what happens here. This would cause a multiplication of the exponents. So this is 2 to the power of 2 times 2 times 2 to the power of 3. So there's plenty of 2's here. And evaluating this exponent would be 2 to the power of 4 times 2 to the power of 3. And if you recall in our first example, when you have the same base and they're multiplied and you have exponents on each of the bases, all you have to do is copy the same base and add the exponents. 2 to the power of 7. So this would be the correct answer. This answer is wrong. This one is right. Let's remember how square roots worked. So this was in a previous video. Whenever you have a square root, and here's the example, or a similar one that I gave in the previous one. If ever you had something like 2 to the power of 4 over 3, that would be the third root of 2 to the power of 4. So a square root is subtle, but it's a bit simpler, it turns out. Let's say the square root of 7. Well, by default, if there's no exponent on something, it's as though there was an exponent 1. And if there's no number in the root, by default, we say that it's a square root, which would be based on the number 2. So if we were to change that to an exponent, it would be 7 to the power of 1 over 2. So that's what we have to do here. 4 squared times 2 to the power 3. There's a square root over the whole thing. So I'm just going to change the square root to be a power 1/2. So anytime you see a square root, you have the right to change it to something to the power of 1 over 2. Now let's remember what we have to do with the 4. We should change this to a 2 squared times 2 to the power of 3, all to the 1/2. Now we can evaluate these two exponents. They're separated by a bracket, so they have to be multiplied. This would make 2 to the power of 4 times 2 to the power of 3. And now these two are separated by their bases and a multiplication, which means they would be added as we did in the first example. And all of this is to the power 1/2. So this would make 2 to the power of 7, all to the power of 1/2. So lastly, if you recall, this makes another multiplication because it's separated by a set of brackets. So this would be 2 to the power of 7 times 1/2. And if you recall in our first video, which was on the multiplication of fractions, we would have to change the 7 to be a 7 over 1. And then we multiply the two numerators together. So 7 times 1 is 7. And then we multiply all the denominators together. So 1 times 2 is 2. And this would be our final answer. All right, here's this one. There's many ways to approach this one, so I'm going to choose one approach, but perhaps you have a different way of solving this. Let's do what we did last time with the square root. So I'm automatically going to change the square root to a power 1 over 2 and keep everything else the same. Now, recall that if ever you had 2 squared times 2 to the 3, you would add the exponents. If ever I wanted to divide an exponent, let's say 2 to the power of 3 divided by 2 to the power of 2, well, a division is the opposite of a multiplication. So the result would just be the opposite. It would be 3. Well, what's the opposite of addition? It would be subtraction. So this would just be 2 to the power of 3 minus 2. This is what's going to happen here with our 5s. If you think of what a fraction is, it's just a division. It's 5 to the power of 5 divided by 5 to the power of 2. So the result would be 5 to the power of 5 minus 2. And of course, we have to keep this 1 over 2 on the outside. 5 minus 2 in the exponent is just going to make 3. And now this here will be another multiplication. 5 to the power of 3 times 1 over 2. We have to change the 3 to be over a 1. And that makes 5 to the power of 3 times 1 is 3 over 1 times 2 is 2. And that's it for the exponent properties. I'll see you in the next video.